In today's lesson, we're going to be solving exam questions on trigonometric identities and equations. Let's take a look at this exam question. There's 3 parts. The first part says to take a look at the diagram. The diagram shows a part of the graph y equals a plus b sine x. Can we now find the values of the constants a and b? So let's take a look. We know that y equals a plus b sine x. From our previous lessons, you should recognize that the value of a will be the value at the intercept. In this case, it's going to be -2, as that is the intercept point. To find the value of b, we have to evaluate the stretch of our sine curve. By comparing it to the original sine curve, we should be able to see the factor that it is being stretched by. From the top of the sine graph to the intercept, the distance is 1. However, on our stretched graph, the distance from the top of the graph to the intercept is 3. So, this shows that our graph has been stretched by a factor of 3. So this must be our b value. So, our answer is y equals -2 plus 3 sine x. In part b, we are asked to show that the equation sine theta plus 2 cos theta multiplied by 1 plus sine theta minus cos theta is the same as sine theta multiplied by 1 plus cos theta, and then show that it can be expressed as 3 cos squared theta minus 2 cos theta minus 1 equals 0. First, we need to rearrange and set our equation equal to 0. Now let's expand the equation. Now simplify. Now we are going to eliminate the sine squared by substituting 1 minus cos squared theta. Finally, we add the terms to simplify and rearrange for the answer. The final part of our exam question is to solve the equation for the range -180 degrees to 180 degrees. To find the solutions in the range, it is best to use the simplified equation. Notice that the simplified equation looks like a quadratic. We can either factorize the equation or use the quadratic formula to solve. Here I have factorized, and you can see that we get 2 values for theta. Theta equals 1 or -1/3. Now let's take the inverse of cos of these 2 values to find our first 2 answers. Here you can see that the inverse of cos of 1 gives us the answer 0, and the inverse of cos of -1/3 gives us the answer 109.47 degrees. Now we need to use our knowledge of cos to find the other answers within the range -180 to 180 degrees. Here is the other answer, -109.47 degrees. So, our final answers are theta equals -109.47 degrees, or 0 degrees, or plus 109.47 degrees. Here is another exam question. Let's begin. In the first part of this question, it asks us to show that the equation cos 2x multiplied by tan squared 2x plus 3 equals 0 can be expressed as 2 cos squared 2x plus 3 cos 2x plus 1 equals 0. We are going to substitute tan squared 2x for sine squared 2x divided by cos squared 2x. Once we do this, we can eliminate the sine squared 2x by substituting it for 1 minus cos squared 2x. Expand the bracket by multiplying by cos 2x. Now multiply everything by cos squared 2x to eliminate the denominator on the first part of the equation. Once we do that, all we need to do is simplify to obtain the result. Part 2 of the exam question asks us to solve the equation in the range of 0 to 180 degrees. Once again, taking the simplified equation, you can see that it is a quadratic. Again, we can either factorize or use the quadratic formula to find the values of x. Here I have factorized, and you can see that the values of cos 2x are -1 or -1/2. Now take the inverse of cos of these 2 values to find our first 2 answers. Here you can see that the inverse cos of -1 gives us the answer 180 degrees, and the inverse cos of -1/2 gives us the answer 120. Now we need to use our knowledge of cos to find the other answers. Here, the other answer is 240. Now, the important thing to remember here is that we have found answers for 2x, not x. So all we have to do is divide our answers by 2 to find the final answers. The final answers are theta equals 60 degrees or 90 degrees or 120 degrees. Here is exam question number 3. Let's begin. The first part of the question asks us to show that cos theta plus 4 divided by sin theta plus 1 plus 5 sin theta minus 5 equals 0 can also be expressed as 5 cos squared theta minus cos theta minus 4 equals 0. When we look at this equation, it doesn't look obvious what to do. However, the first part of the equation is divided by sin theta, so that means I'm going to have to multiply by this at some point to eliminate it. So, if I factorise the 5 sin theta minus 5, this should give me something that I can more easily work with. Now multiply by sin theta plus 1. Expand the brackets and simplify. Now we can replace the sin squared theta with 1 minus cos squared theta. Expand the brackets again and simplify to our answer. Part 2 of our exam question asks us to solve the equation in the range of 0 to 360 degrees. Once again, taking the simplified equation, you can see that it is a quadratic. Again, we can either factorise or use the quadratic formula to find the values of x. Here I have factorised, and you can see that the values of cos theta are minus 4/5 or 1. Now take the inverse cos of these two values to find our first two answers. Here you can see that the inverse cos of minus 4/5 gives us the answer 143.13 degrees, and the inverse of cos of 1 gives us the answer 0 degrees. Now we need to use our knowledge of cos to find the other answers. Here are the other two answers, 216.87 and 360 degrees. So our final answers are theta equals 0 degrees, or 143.13 degrees, or 216.87 degrees, or 360 degrees. All the practice paper questions are posted on Google Classroom. Good luck! So that's it for today. Please remember to check out YouTube for all the videos that are related to our lessons. And also, don't forget to check Google Classroom that has all the practice material and the quick practice tests. Thank you, see you next time.